Good evening, everyone. So I think we are all set. You all can see the screen and let's start. So the last time we were discussing the second purpose of of the potentiometer, right? That is to measure the internal resistance, right? That is to measure the internal resistance of a cell, right? So let's repeat the method very quickly. Can you all hear me? Am I speaking loud enough? Okay. Right. Very good. So I was saying that we have talked about this, that if you want to measure the internal resistance of a cell, first of all, we connect it just like this, right? So that's the diagram you're seeing. We find the null point and let's say which is at a length L. So we get epsilon equal to phi L, right? Epsilon is the EMF of this cell. This cell has EMF epsilon dash, right? Okay. Then we connect a known resistance R here, which is parallel to this cell, right? Whose internal resistance we want to find. Okay, right? That's what we are seeing here. So I asked you, and we stopped here, right? I asked you that when we connect an resistor R in parallel like this, right? What's going to happen, right? What's going to happen? Will we get the same null point? What do you think? Will we get the same null point? Will we get the same null point, everyone? What is your idea about it? Okay, right. Well, the answer is no. No, they are not going to be same. They're not going to be same, right? Let's see why. Okay, let's see why they're not going to be same. So now, if you will think of this resistor R, right? I'm sure all of you understand that there will definitely be a current through this resistor R, right? See, if you cannot imagine why there would be a current, let me tell you why it would be, right? Let me make the reason clear. See, if you find a null point, there's definitely some potential difference between the point A and N dash, right? This is not going to be zero. This is some value. So do you see that ultimately this resistor R and this point, they are going to be connected in parallel? Yes or no? Yes or no, everyone? Right? They are connected in parallel. So because there is a potential difference between A and N dash, there's obviously going to be a potential difference between the two ends of resistor. So that means there is a current. There is a current flowing through the resistor, right? Okay. You can also understand it like this. All right. So have a look. Okay. Let me just you know, you can also understand it like this. Because see, because there is no current in galvanometer, so there is no current here, right? No current here. But this battery is ultimately connected with a resistance R. So there will be a current like this flowing through this resistor. Did you understand this? There will definitely be a current flowing like this. That is because of this cell. You understood this? Is I1 clear, everyone? Is I1 clear? So basically what we are having is there is current flowing here in the resistor R, and there is current going through the battery also, right? There is current going through the battery, but there is no current in galvanometer because we are talking about null point, right? Because we are talking about null point, there is no current here. So over here current is 0, over here current is 0. So basically the current is just making a loop. Clear? Yes, it does not reach galvanometer. That's right. તો જ null point આવે ને. Remember, we are doing this practically. Remember, we will slide this until we find a null point. એટલે એમ ન કહેતા સર null point કેમ આવ્યો? તો null point આવે, right? And when we have the null point, right? When we have the null point, this is the situation. Is this whole circuit diagram clear? All the currents clear? Everyone, have you understood all the currents? અહીંયા તો કરંટ હશે જ. જે આ વાયર છે, this is potentiometer wire, right? Here there will definitely be a current I. But we are not concerned about that. This is of no importance, right? What is important is this 0, and what is important is this I1, right? Okay, now can you tell me which, suppose here we measure this length. Now this diagram has become really tough to observe. Let me just zoom into it. All right, so I'm saying here when we measure this, or when we find this new null point, when we find this new null point n dash, let's say this length is L dash. Clear? Did you mark it in your diagram, everyone? Let's say this length is L dash. So let's also write it. Okay, so we'll have to go to the next page because here the space is all over, right? Okay, I'm going to the next page. So you could write, let the null point n dash in this case be at length or distance. Once again, whatever you want to write, you could write it anyways, L dash from A. Okay, so this is the new null point. Second situation, right? This is the null point in the second case, right? When we connect that external resistance capital R. Okay, now I just want a little bit of prediction from your side. What do you think? Which is bigger? Which is bigger? What do you think? Simple prediction from your side. Come on. જોઈએ તમારું intuition કેટલું develop થયું. Which is bigger, L or L dash? Okay, and for that you could take help of this diagram, right? What do you think is bigger? Okay, what is L, Avinash? Were you paying attention yesterday? All right, the correct answer is L dash is smaller, right? This is the correct way. L is bigger, this is bigger, right? That's because That is because current is not flowing in this case. In the first case, current is not flowing. That's why that length is bigger. So if current is not flowing, you are actually measuring EMF, right? Okay, anyways, in this case, so in this case, V is equal to epsilon minus I1R is equal to phi L dash. Is this equation clear? Is this equation clear? I want all of you to focus. આ ડાયાગ્રામ ફરીવાર ડ્રો કરું છું, પાછળ જોવું ન પડે એટલે. I want all of you to focus on this part. Is this clear? કારણ કે ટર્મિનલ વોલ્ટેજ આવશે ને, હવે EMF નહીં આવે, ટર્મિનલ વોલ્ટેજ આવશે. I hope you get why. Right? And I'm sure all of you know that terminal voltage is smaller. Terminal voltage is always smaller than this, than the EMF. That's why L dash is also smaller than L. I hope you got it now completely. Those who did not understand that earlier, right? I hope now you understood this completely, right? ટપ્પો પડે છે ને કે ઉપરથી જાય છે બધું? So what's the whole method again? What's the whole method? Step 1, just connect only the cell, right? Don't connect anything, connect only the cell. So when we find null point, no current is flowing, right? No current is flowing, and that's why you are measuring EMF, and that EMF is equal to phi into L. Now second case, connect cell and resistance in parallel, right? So what happens here? Current will flow. How much current will flow? I1 will flow. All right. Now if I1 is flowing, then you are going to be measuring the terminal voltage, which is going to be epsilon minus I1R, right? And that is equal to phi L dash. આટલું કર્યું છે અત્યાર સુધી આ મેથડમાં, બરાબર ને? આખી અત્યાર સુધીની મેથડનું બધું આવી ગયું, right? Okay. Now, so we will divide these two equations. આ 1 2 મેં લખી ને, આ સેકન્ડ છે, બરાબર ને? ફર્સ્ટ હતી આગળ, right? I hope you understood what is the first. This is of course the first, right? So we divide 1 and 2. What do we get? We divide 1 and 2. What do we get? આ લખવાનું હો પેપરમાં. Dividing 2 by 1 કરો ને. Dividing 2 by 1. તો શું થાય? Epsilon minus I1R upon epsilon is equal to L dash upon L, right? Just dividing equation 2 by equation 1. ચૈત્ય કેમ શું થયું? Okay. See, if you have not understood, for anyone who might not have understood this equation, I'll say use Kirchhoff's voltage law in this loop. Sorry. Yeah, in this loop only. All right. If you use Kirchhoff's voltage law in this loop, you will get this equation, right? જેવી રીતે આગળ કર્યું તેમ. Okay. Now you just have to simplify this. Now you just have to simplify this. All right. I1 ની ફોર્મ્યુલા તો બધાને આવડે છે, મને ખબર છે, બરાબર ને? So here this would become epsilon minus epsilon upon R plus R. Clear? Okay. I hope you all realize that this battery is only making current flow through this R and this R, right? This battery epsilon only makes current flow in this loop, in this rectangle, બરાબર ને? એટલે જ R plus R આવ્યું, right? We don't need to write anything else. Okay. So then rest is maths. You just have to simplify. Epsilon common cancelled. LCM R plus R minus R upon R plus R is equal to L dash upon L. Okay. So take reciprocal. All right, everyone, take reciprocal. I'm just writing it here. I've taken inverse or reciprocal. How are you? આ તો મેથ્સ જ ચાલે છે, આમાં કઈ છે નહીં, ઓનલી મેથ્સ. So that's it. This is your final step. Okay. તો જો આમાં ઇક્વેશનમાં શું છે? L dash measured, L measured, right, by doing experiment, and R should be known. Clear? Okay. Any questions in this part? Chapter ni theory puri. બરાબર ને? Any questions, anyone? નીચે વાળું EMF વધારે હશે તો શું? કયું નીચે વાળું? તો ઈ તો વધારે જ હોય, everyone. Let's make it clear. E dash, the primary, this primary cell or primary battery must have more EMF. એના વગર તો આ એક્સપેરિમેન્ટ થાય જ નહીં. કેમ? કારણ કે આ ફર્સ્ટ પોઈન્ટ જ નહીં આવે. I hope you get that. I hope everyone gets that. એના વગર તો બેલેન્સ જ ન થાય ને. ગઈકાલે જ આવ્યું હતું. બહુ વધારે હશે તો પૂર્વેન્દ્ર, this is a man made instrument. એટલું સમજવાની જરૂર છે. Right? This is a man made instrument. Okay? તો instrument generally આપણે એવું જ બનાવીએ ને કે જે useful હોય. So if you take this to be very high, then n and n dash will be very close to each other. તો બહુ સારું કામ નહીં કરે. Right? So we can make it as we wish, right? Okay, K asks question. What's the use of E dash? Okay, K, I have not answered your question. Don't say okay, sir. Now I'm going to answer your question. K is asking what's the use of this primary cell? All right? Okay? See, K, if you don't connect this here, suppose અહીંયા battery no લગાડો, right? Then I hope you understand that there is no way you can get null point here. કારણ કે એક જ બેટરી હોય તો અહીંયા કરંટ તો ફ્લો થાય ને થાય જ. Agreed? Yeah, I hope you got it. Right? So that primary cell or primary battery is necessary. Without that, potentiometer will not work, right? Okay, એટલે જ હું કહું છું કે આ જે ઇન્સ્ટ્રુમેન્ટ છે બરાબર, આ નેચર નું નથી, right? What I mean to say is you can you can probably ask questions like what if the electric field is like this, right? Or what if there is square shape of a conductor. એવા બધા question હજી પૂછી શકાય because conductor is not man made and also this shape is not man made, right? But like I've said, this is an instrument. તો એ તો આવી રીતે એટલે જ બનાવ્યું કારણ કે આમ કામ કરે છે. If you remove this, it's not going to work, right? ચલો, I think that's enough for this potentiometer. If there any resistor with E dash, will it create any difference? Yes, actually. Yes, thank you for reminding me. Thank you for reminding me. એટલે 5-4 લોકો વયા ગયા, વાંધો નહીં. ચલો, તમે એવું લાગે છે કે તમે 3 ચેપ્ટર સુધીનું જ ભણવાનું નક્કી કર્યું હશે. Okay, never mind. To answer that question, this is actually a very simplified circuit. તમારી ટેક્સ્ટબુક ની સર્કિટ હવે હું તમને દેખાડું છું, બરાબર? I hope nobody is low on glucose. It's possible that you might just fall down, right? You might just fall off your feet. કારણ કે એ લોકો એને unnecessarily complicated બનાવી છે. I'm going to shamelessly copy that circuit from the book, right? મને આવડે છે ડ્રો કરતા, કોઈ એવું ન વિચારું કે નથી આવડતી, બટ I see no need for me to draw કારણ કે તમારી બધા પાસે ટેક્સ્ટ બુક છે. મારે જે કંઈ તમને ઇન્ડિકેટ કરી દેવું છે એ હું ઇઝીલી કરી દઉં, બરાબર ને? મારે શું કામ આખી ડ્રો કરવી જોઈએ પરિવાર? ઓલરાઈટ, હિયર ઇઝ પોટેન્શિયોમીટર, right? So this is for comparing EMF. This circuit is for comparing EMF, right? Okay. So what do we see here? What do we see? First of all, this is that primary. Is that clear? This is the primary. Okay, this one, right? Here is that large resistance connected so that current is always small. Clear? Here is that large resistance connected so that current is always small. This is switch or key, એટલે on off કરી શકાય, right? Okay, next you see from A to C is there wire. અહીંથી આમ પછી અહીંયાથી બેન્ડ કરીને પાછો આમ, એટલે અહીંયા છે ને કોપર પ્લેટ હોય. This is a copper plate, thick copper plate with negligible resistance. Okay, thick copper plate with negligible resistance. Okay, પછી અહીંયા પાછો આમ બેન્ડ કરીને આ બાજુ અહીંયા આમ અહીંયા આમ અહીંયા આમ આટલો લાંબો. See the purpose, long wire. એવું આવ્યું હતું ને ઓલા સમમાં, યાદ છે? યાદ છે કે નહીં? ઓલો એક એડિશનલ નો ક્વેશ્ચન સોલ્વ કર્યો તો આપણે. Copper plate is used so that you don't have to bend the wire. અહીંયા છે ને સ્ક્રૂ હોય, અહીંયા સ્ક્રૂ પર ભરાઈ દેવાનો, પછી આટલામાં કોપર પ્લેટ હોય, પછી અહીંયા પાછો એક બીજો વાયર લઈને અહીંથી અહીંયા ભરાઈ દેવાનો, so that you don't have to bend the wire. You can use pieces, right? I hope you understood. You can use pieces of wire, right? આવી રીતે સ્ક્રૂ ટુ સ્ક્રૂ. આ બહુ પ્રેક્ટિકલ છે. આને ખરેખર ફિઝિક્સ સાથે કંઈ લેવા દેવા નથી, ખાલી આમ કેવી રીતે બધું ગોઠવાય એવું છે. ઓકે, સો અગેન that's the use of long wire. જનરલી આ વાયર છે ને 5 મીટર જેવો લોંગ હોય, તો એવડું મોટું સ્ટ્રેટ ટેબલ કોણ રાખવાનું? આમ લાંબો 5 મીટરનો ટેબલ, પછી એમાં કેવી રીતે મેળ પડે? અને જોકી તમે આમ સ્લાઇડ કરવા જાઓ તો 5 મીટર દૂર ચાલીને જવું પડે. I hope you understood what I'm saying, right? That's why it is bent. Clear? I hope you also understood why it's bent, everyone. એટલે આમ લાંબુ ચાલીને ન જવું પડે. એન્ડ ટેબલ કેન ઓલ્સો બી સ્મોલ, રાઈટ? થિંક હાઉ ઇનકન્વીનિયન્ટ વુડ ઇટ બી. ઓકે, નાવ this is the common part. આટલું તો આ પ્રાઇમરી હતું, બરાબર ને? આટલી પ્રાઇમરી સર્કિટ, રાઈટ? સો ફાર વી હેવ ટોક્ડ અબાઉટ primary circuit. હવે બીજું શું છે? Let's see. So now I'm going to mark the secondary circuit in green. All right? Okay, from here you see, forget two cells. Okay, ignore two cells right now, just look at one cell. Okay, just look at one cell. સમજાઈ ગયું? Ignore this also. સમજાઈ ગયું કે નહીં? આટલું સમજાઈ ગયું? Whatever is shown, this is connected. આ સ્વિચ છે, right? This is a two-way switch, right? This what you are seeing here, this is a બહુ zoom out કરી નાખ્યું ને, એટલે this is a two-way switch. એટલે એકવાર આમ કનેક્ટ કરવાની, એટલે આ ફર્સ્ટ બેટરી કનેક્ટ થઈ ગઈ, સમજી ગયા? Then second time you connect it here, આમ કનેક્ટ કરી નાખવાની, એટલે આ બેટરી કનેક્ટ થઈ ગઈ. Understood? Clear? So this is, હવે આવું બધું તમે સમજવા જાઓ, એમાં ઓલો જે ફિઝિક્સ સમજવાનું છે એ કોને આવડે? Think about it. Practically આમ જ કરાય. See, let me tell you, this is a practical diagram, but it is not the easiest one to understand, right? આવું મેં તમને પહેલા સમજાવ્યું તો તમે બધા હજી આમાં જ અટવાયેલા રહેત કે આ બધું શું છે, આવું તો કઈ ખબર નથી પડતી. પછી અહીંયા જ્યાં કિર્ચોફ લો યુઝ કરવાનો હોય અહીંયા ન ખબર પડે, આમાં વાયર જતો હોય. Right? So I hope now it is clear what this diagram is. એટલે એકવાર આમ કનેક્ટ કરવાનું, એટલે એપ્સિલોન 1 આવે, એટલે ઇક્વેશન આવે એપ્સિલોન ઇક્વલ ટુ 5 into L1. પછી આ બાજુ કનેક્ટ કરો એટલે શું આવશે? બીજો નલ પોઈન્ટ આવશે N2. So you get epsilon 2 equal to 5 into L2. પછી ડિવાઈડ કરી નાખો એટલે આન્સર આવી ગયો. જો એક્સપ્લેનેશન પૂરું. કેટલું શોર્ટ એક્સપ્લેનેશન હતું? Okay, now second one. All right, that is easier than this. Second one, okay. Okay, right. So now what's with this one? First of all, this key is kept open. Open એટલે off રાખી, બરાબર? First of all, we keep it off. સમજાણું ને? તો આ કંઈ છે નહીં એવું માનો, આ કંઈ નથી, આટલું જ છે. So what are we measuring? We are finding the first null point. So epsilon is equal to 5 into L1. આવી ગઈ without resistance, બરાબર ને? પછી સેકન્ડ ટાઈમ શું કરવાનું? આને ઓન કરી નાખવાનું, રાઈટ? Okay, you understood that? And here there is some known resistance. Here there is some known resistance. RB मतलब resistance box. RB मतलब resistance box which gives known resistance. Okay. તો એ કનેક્ટ કરી નાખ્યો એટલે સેકન્ડ કેસ. સેકન્ડ કેસ શું આવ્યો આપણે? V equal to epsilon minus I1R equal to phi L dash. અહીંયા ખાલી L લખો તો વાંધો નહીં. Phi L and V equal to phi L dash. સમજી ગયા? So this time current will flow like this. I hope you got that. I1 current will flow like this. Okay? આ છે ને, તમે જ્યારે પ્રેક્ટિકલ કરશો ને ત્યારે તમને ખબર પડશે કે આપણે તો કેવી મસ્ત સર્કિટ ડ્રો કરીએ આવી રીતે, બરાબર ને, આવું રેક્ટેંગલ જેવું ડ્રો કરીએ. એકચ્યુઅલી તમે વાયર ગોઠવવા જાઓ તો વાયર તો કેવો હોય, આમ અહીંયા કનેક્ટ કર્યો પછી આમ 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 ક્યાંય લબડતો છે ને આમ જઈને પછી આમ આવશે, અને એવી રીતે આ બાજુનો વાયર એ આવા, તો થોડીક વાર તો તમને ખબર નહીં પડે કે આ શું ડ્રો શું છે. આઈ હોપ યુ અન્ડરસ્ટેન્ડ વોટ આઈ એમ સેઇંગ. બરાબર ને, પ્રેક્ટિકલી તો વાયર કઈ થોડો આમ સીધો રહેવાનો છે. એ તો જોયો જ ને તમે, તમારા ઘરમાં ઇલેક્ટ્રિશિયન ક્યારેક કામ કરે તો વાયર તો તમે જોયો છે, એ તો કેવા આડોળો આડોળો જતો. સો ઇટ્સ અ રિયલ ચેલેન્જ ઇન પ્રેક્ટિકલ. એક્ઝામમાં કયો ડાયાગ્રામ ડ્રો કરવાનો? બુકનો, ઓફકોર્સ બુકનો. બરાબર ને, ડ્રો ટેક્સ્ટ બુક ડાયાગ્રામ્સ ઇન એક્ઝામ. જો નો આવડે તો પછી મેં સિમ્પ્લિફાઈડ ડ્રો કરાવ્યો એ કરાય. ઓકે, but prefer the textbook diagram, everyone. Okay, all right, I think that's enough of talking about this, right? Now, one important point. Do you know what is a voltmeter? How many of you know what's a voltmeter? If you know, can you tell me what is a voltmeter? Do you know what is a voltmeter? Okay, very good. We have got 3 correct answers. Okay, ચલો, ઘણા બધા લોકોને ખબર છે. And your understanding is, suppose we will connect a battery. Suppose we connect a battery, right? Let's say that this has no internal resistance. એવું તમે વિચારો. ના રાખવું પડશે, હું જે કહું છું એ સમજાવવા માટે. Let's say this is 12 volt and 1 ohm, right? And here you connect let's say 11 ohm resistance. Barabar? So you can, in theory, right, that is by calculations you can find out that the potential difference between the 2 points A and B, the potential difference between the 2 points A and B is going to be I into 11, correct? IR, Ohm's law, is going to be I into 11, that is Ohm's law, right? Okay, so how much is the current? Pehla hi find kar le. How much is the current? If we find the current is going to be 12 upon 12, that is 1 ampere, right? Current is 12 upon 12. યાદ છે ને આ બધાને કે ભૂલી ગયા? તમે જૂનું બહુ ભૂલી જાઓ છો, I know that. આવું આવે ને? Okay, so what do you think this is going to be? 11 volt, right? Okay, બરાબર ને? But you know, there is a problem here. Theory માં તો બરાબર. Suppose now you connect a voltmeter which is always connected in parallel like this, right? અને એ voltmeter ને છે ને આવું ડાયલ હોય, right? જેમ સ્પીડોમીટર ને હોય ને એવી રીતે. So there is a needle, it will show how much is the voltage between 2 points A and B, right? Okay, so then that voltmeter's reading ખબર પડે ને? યાદ છે ને બધાને what is reading? Reading means measured value. I hope all of you remember that. થોડાક તો પ્રેક્ટિકલ કર્યા છે ને 11th માં. Reading means the measured value, right? So it will not show 11 volt. Okay, let me tell you, it will not be 11 volt. The reason is Very good, Himani. Well done. I'm glad you know that. The reason is that because whenever you connect anything in parallel like this, બરાબર, તો એનું પોતાનું કંઈક રેઝિસ્ટન્સ હોય. Suppose this voltmeter, resistance of this voltmeter that you are using is, let's say, 10,000 ohm. Okay, આ સારું કહેવાય voltmeter, 10,000 ohm. So it's that now here it's like there is 10,000 ohm, right? But I'm sure you realize that some current will definitely flow here. એટલે જે પેલા 1 એમ્પિયર કરંટ હતો ને, એ હવે અહીંયા 1 નહીં આવે, અહીંયા થોડોક ઓછો થઈ જશે. Maybe something like this. I'm just giving an example. Value મેં calculate નથી કરી. I'm giving an example. You understood what I did here? Yes or no? So some of you might say એવું ન કરી શકાય કે અહીંયા કરંટ જાય જ નહીં. તો હું એમ કહીશ કે અહીંયા કરંટ ન જાય ને તો એ મેજર શું કરી શકે? ઓકે, આ એનું રીઝન સમજાવ્યું અવિનાશ. તે કીધું એ બરાબર, આ એનાથી એક લેવલ આગળ કરંટ થોડોક ડાયવર્ટ થઈ જશે, રાઈટ? So this small current is diverted. So now it will actually be showing 11 into 0.98. I hope you all get that. બરાબર ને? આવો આન્સર આવશે. So that's going to be 8 and 7 and carry 1 and 9 and 10.78 ampere. Suppose out sorry, volt. So you see this is not going to be level, right? Okay, but still voltmeter can measure voltage. Voltmeter can measure voltage. Slight error is there, I agree. Voltmeter can measure voltage. There is of course slight error, right? But suppose you want to measure EMF. Let's say we want to measure EMF of battery or a cell. See, the problem is weird. I'll tell you why. Let's say this is that battery, 12 volt and 1 ohm. બરાબર, મારે આનું EMF measure કરવું છે. What is definition of EMF? Can the knowledgeable students of knowledgeable teacher tell me what is EMF? Avinash, your language is too much like someone who is knowing electronics. I hope you'll be able to cope with me because I hate electronics. Yeah, I sensed that, right? Yes, EMF is actually the terminal voltage. EMF is same as terminal voltage, but when current is 0, right? That means open circuit, right? I hope all of you understand that, right? તમે બધા કીધું ઈ જ છે. What you said is right. Potential difference between positive and negative terminal means terminal voltage, right? When current is 0. So if you connect this directly, ચલો આપણે આનું સીધું જ measure કરી લઈએ. તો મળી જાય EMF. Can you find EMF like this? Can you find EMF like this? Yes, very good. So by doing this, we can measure, by doing this kind of experiment, we can measure terminal voltage. We can never measure EMF. I hope you understand that, right? You can only measure terminal voltage, never EMF. Okay, there will definitely be an error. right? There will definitely be an error, right? Guaranteed. એટલે આ method જ ખોટી છે. I hope you understand. Method is wrong. Correct? I hope you realize that the method itself is wrong. કારણ કે આપણને થિયરીથી જ ખબર પડે છે કે આમ ન કરાય. Agreed? So, I hope you realize this is what potentiometer does wonderful. હવે તમને ખબર પડશે કેમ potentiometer use કરવું છે. Potentiometer is like some magic trick, isn't it? Right? No current flows. Potentiometer technique is like magic trick. No current flows and yet we can measure. Do you agree with this sentence? Do you agree with this sentence? No current flows and yet we can measure the voltage. છે ને જોરદાર. So that is why potentiometer is superior. That is why potentiometer, in my view, is a superior device compared to voltmeter, right? બેટરીને ડીંગો દેખાડી દીધો, લે 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 કરંટ ન લીધો ને મેજરે કરી લીધું, લે એવું કંઈક. Okay, so please keep that advantage of potentiometer in mind. With that, we are done with the theory. Let's solve questions in the remaining time. Okay, ફોર્મ્યુલા બધી યાદ રાખજો પોટેન્શિયોમીટરની. અને છેલ્લે કંઈ ન આવડે તો મેં શું કીધું હતું, પેરેલલમાં વોલ્ટેજ સેમ હોય, કરી નાખવાનું, થઈ જ જાય. Right, now we are going to solve example 10. Everyone, example 10 from the book. ક્યાં છે? આ રહ્યો. Okay. So here is the question. Now let's read it. Resistance of R ohm draws means takes current from a potentiometer. આમાં potentiometer ક્યાં છે? આ potentiometer ની primary છે, everyone. This is primary. Clear? So here what you can do is, instead of this V, you can just think of it like a battery of voltage V, right? That will do. Okay, no internal resistance, nothing. So potentiometer wire or everything in the potentiometer has total resistance R0. Okay, so this whole thing has resistance R0. Clear? A voltage V is supplied to potentiometer. Okay, derive an expression for the voltage across R. એટલે આ બે પોઈન્ટ વચ્ચે potential difference શું આવે એ find કરવાનું. Okay, we want to find what is the potential difference between these 2 points. આને કંઈક કહી દે, DE. Right, so we have to make a formula of VDE. Right, when the sliding contact એટલે jockey, એવું લખવામાં શું જતું હતું? When the jockey is in the middle of the potentiometer wire, એનો મતલબ અડધું resistance left side અને અડધું right side. Avinash, do not guess. Did you understand this, everybody? અડધું left side, અડધું right side, એટલે બે side R0/2, R0/2. Okay, right? Uniform, remember potentiometer wire is uniform, right? Okay, So now we want to find out how much is the, તો આન્સર ચેક કરી લે ને અવિનાશ, ગેસ નો કર્યો હોય તો ચેક કરજો, આન્સર આવી ગયો. I don't think it will be that simple. Okay. See, frankly speaking, this question has nothing to do with potentiometer, right? Okay, this is simple series parallel question in my opinion. Let's start. So if you look at this circuit carefully, do you agree that I can draw this circuit in my own way like this, and I'm sure you will not object? Okay, do you agree with this? Yes or no? અહીંયા B છે. So now it's so easy. If we want to find VDE, here is my plan. Listen to this. Here is my plan. We will find how much current flows through this, અને આ બે તો પેરેલલ માં છે, R0/2 ને R, એટલે એનો કોમન વોલ્ટેજ આવી જાય, એ જ આપણો આન્સર, રાઈટ? ઓકે, so let's start. So modified form of circuit. Okay, આ બધા ડાયાગ્રામ ડ્રો કરજો, તમે લખજો circuit is as shown. Okay, પછી હવે એને સિમ્પ્લિફાઈ કરવાની. Okay, so now next step. Call this R dash and then R0/2. Right? અહીંયા current I છે. Right? Where clearly, આ બધું લખજો બરાબર, where R dash is equivalent of R0/2 and R. Okay, so what is R dash equal to? It is equal to R0 R/2 into R0/2 plus R. આ કઈ ઓલી શોર્ટકટ યુઝ કરી પેરેલલ ની, R1 R2 upon R1 plus R2. Okay, લખાઈ ગયું એટલું? Right, you could simplify this if you want. This is going to become R0 R upon 2 R0, sorry, upon R0 plus 2R. આ યાદ છે ઓલો કેપેસિટન્સ નો ક્વેશ્ચન હતો જેમાં બહુ સિમ્પ્લિફાઈ કરીને પછી આપણે ચાર્જ ને વોલ્ટેજ ને એવું ફાઇન્ડ કરતા હતા, આમાં થોડુંક એવું જ કરવાનું, રાઈટ? ઓકે, નેક્સ્ટ સ્ટેપ. Next step is current through circuit or through battery. Okay, battery નો લખો તો સપ્લાય લખો તો ચાલશે. સપ્લાય એટલે V વોલ્ટેજ જે છે ને, રાઈટ? I is equal to V divided by R dash plus R0/2. Okay, therefore potential difference across R, that is equal to VDE, that is equal to I into R dash. Bracket માં ઓલું parallel વાળું reason, in parallel voltage is same, right? Clear this step? I'm waiting for you, everyone. Can you please say yes or no? ફિગર જોતા રહેજો, બધું ફિગર માંથી જ છે. મેં તો ફિગર ગોખી નાખ્યો એટલે મારે પાછળ ન જવું પડે. ઓકે, so finally, અરે બધાને નથી સમજાણું લાગતું, હજી તો થોડાક લોકોએ યસ કીધું, Is there some problem? You can ask if you have a problem. People, don't be shy. તમે તો ઓળખો જ છો મને. R dash is not clear. Okay. This one? અરે parallel ની formula. R dash is equivalent of R and R0 by 2. In VD, okay. For that, Swarali, we must see the circuit. Look at R dash. R dash was made from R0 by 2 and R, correct? And these two are in parallel, right? These two are in parallel, so the voltage should be same, right? So if I want to find VDE, instead of finding VDE, I will just find what's the potential difference between these 2 points, right? So current I will flow, so IR dash is VDE, right? Okay then. So now let's put values. V upon R dash. અરે એટલું બધું કેલ્ક્યુલેશન કરવું છે. R0 R upon 2 ના શું હતું? R0 plus 2R. Okay. This is only I's value. Remember, this is only I's value. Clear? ના હજી લખવાનું છે. એક મિનિટ. Sorry. Just a minute. I'll just do it again. Okay. Instead of I, let's write V upon R dash plus R0 by 2 and then into R dash. Okay. I just found a simpler way, maybe. Instead of R dash, let's write R dash's value. It is R0 into R upon R0 plus 2R plus R0 by 2, and here also I'm going to write R0 into R upon R0 plus 2R. Clear all of this? Right? હવે મેથ છે, આમ LCM લઈ લેજો, આન્સર આવી જશે. ઓકે. Right? So that's it for this question. Okay. તો આવો આન્સર આવ્યો. અવિનાશ V/2 તો ક્યાંય ન આવ્યું, બરાબર ને? ઘણું અલગ આવે. It's actually unintuitive because when you connect this half here, એટલે આ જે બે પેરેલલ માં થાય ને એટલે એવું નથી થતું. Right? I hope you get what I'm saying. આ નો હોત ને તો એવું થાત. Right? But because of these two in parallel, things change. Okay, so that's that about this question. Right now, I'd like to give you some homework. Right, okay, I'm back just in time to give you homework. Don't go anywhere. We have one crucial minute. So I was thinking I'd give you question number 23 in homework. Yes, I will. Okay, I will. Question 23 is homework, everybody. Exercise I hope everyone got my message that question 23 is homework. right? Okay. And question 6 and 20. Question 6 and question 20 is homework. Question. All right. 6 and 20 both have been given. All right. I didn't realize that. Never mind. I think that's it then. That's it. Right? We have one or two worthy questions remaining now. We'll solve those the next time. Okay. That's it. Goodbye, everyone. You can leave, no problem. I won't tell you anything else. Okay. Yes, there are network problems on my side. Okay. Meeting ends.